Okay, Assalamualaikum and very good morning to all. Okay, so last Monday we stopped at this electric field due to continuous charge distributions. Okay, so anybody have any problems for the slides before, or probably the Coulomb's law? Anyone? Semua okay ke for the questions?
So far, okay, madam.
So far okay. All right. Okay, so for this Coulomb's law, so normally you are given with these numbers of charges. Okay, so let's say these examples. Okay, so I just repeat again. Okay, so as an example for these questions, you have two charges. So what you have to do is that you need to find the force that act on Q1. So what you can do is that by applying the equations, so the equation is this thing, okay? So you need to know where your source and where your destinations. So as for these questions, okay, so your source will be the Q2, okay, and your destination will be Q1 because the question want you to find the force on Q1. So Q1 will be your destinations, okay. So for that, your force will be F21, okay, from 2 due to the force at 1 due to 2, okay. So force at 1 due to the charges at Q2, okay. So this is the equation. So it's equal to Q1 Q2 divided by 4 pi epsilon naught with your position vector ataupun dia punya magnitude of it, okay. And this is the distance vector R21. So for these equations, first thing you need to know is each of the parameters value. So first, the distance vector R21 will be, because it is R21, so you need to take the one that you want to find. Okay, so let's say this you want to find the force at Q1, meaning that the positions at 1 will minus the positions at 2. Okay, so remember that. So because of you want to find the force at Q1, okay, so you need to take the position at Q1 minus the positions at Q2. All right, so you will get this value. So remember, this is still a vector. So you need to write something like negative 4ax minus 3az. Okay, and then from there, another parameters that you need to know is this magnitude of your uh, distant vector just now. So what you can do is just take the value from here. So for this one will be negative 4 squared, okay, and plus negative 3 squared. So again, whatever negative, when you square and square root, it will hilang. Okay, so the answer for this is equals to 5. Okay, so substitute inside the equations and you know the value for Q1 and Q2. And this one, 1 over 4 pi epsilon naught will be 9 times 10 power of 9. Okay, so substitute inside this all together and then you will get this. Okay, you will get this answer. All right, so the force at 2, 1 will be negative 0.144 ax minus with 0.108 az, and the units is Newton. So don't forget the units. Okay, and this is another example. Okay, for this one, this is example for multiple charges. Okay, instead of just now we have two charges and now we have three. All right, so for this one, what you have to do is that you need to find the force at uh, 10 nanocoulomb charge, which will be here. So for this question, I just name this position will be Q1. Okay, this charge will be Q1, and then Q2 will be this value position over here, the coordinates, and then Q3 will be 3, 2, -1. Okay, for this one. All right. So again, if you have a questions like this and the figure is not given to you, okay, what you have to do first, please draw the figure for it so you can see which is the source and which is the destination. Okay, so make sure you draw where is your charge and where is your source and where is your destination, so it can be clear kat mana yang kamu kena cari. Alright, so again, okay, so now for this question, you need to find force and then you need to find E at point Q1 ataupun at charge Q1. Okay, so what you have to do, you have two forces that you need to find. So F21, okay, source at 2, okay, and then find at 1, okay. So you need to find the force F21 and you need to find the force for F31. Okay, so force total will be F21 plus F31. Okay, so you either can do it something like this, okay, one by one. Okay, you find F21 first until it finish, and then next you find F31 pula, okay, until it's finished, and then lastly you just sum up both of the forces, which is F21 and F31, or you can do it by sum up everything together like this. Okay, so let's say this is Ft equals to F21 plus F31. You know that the equations for force will be Q1, Q2, this one, okay, R21 divided by the value here, the parameters here, and same goes for the F31. Okay, and then you can see here Q1 over 4 pi epsilon will be the same for both. So take it out, okay? And then you just need to calculate only this. All right. So again, find what is R21 and what is the magnitude of it. And next, find the R31 and the magnitude of it. And substitute inside these equations. And you will get your forces for this. Okay, the combination or the F total will be negative 652 AX minus 372 AY plus 752 AZ a millicoulomb or yalah, for this one is E. Okay, and for E you need to divide by Q. Okay, and then this whole thing will be the answer for your electric field intensity. Okay, and it's volt per meter unit. Okay, kilovolt per meter unit. Okay, so this is the simpler approach, and this is the you do it one by one. Okay, so this is F31 and this is F21. So find it one by one and then find the total of it. All right, so this is the value of F total in millinewton. Okay, right. The next questions. This is the question. These questions is a bit similar with the last one just now, but the only difference is that you are not given with this value of Q2. Okay, so what the question one is that you need to find the value for Q2. All right, and there is no forces or no electric field intensity is given to you. So what you have to do is that do it the same way using the Coulomb's law, where you need to use the um, F1t, because need to find here, right? So F1t equals to Q1 QT divided by 4 pi epsilon R magnitude, right? the equations. So you need to find F1T and also FQT, okay, for both. All right. Okay, you can see here. So you need to find the distance vector first for this R1T, and then the magnitude of it. And you have the distance vector of R2T and the magnitude of it. Okay, so substitute everything here inside the equations. Again, you have something like this. Okay, and then take it out, the one that is similar for both. Okay, so in this case is QT over 4 pi. 4 pi, jangan lupa 4 pi. 4 pi epsilon naught. Okay, and find this value ataupun substitute the value for this for both. Okay, and then you get this. All right, so when you simplify, it will be something like this, which is QT 4 pi epsilon naught, and this is this part, okay, and this one is this part. All right, so now, how you want to find Q2? How can you settle down these equations? Okay, so you already know Q1, okay, so you can just substitute Q1, and you need to know what is Q2. Okay, and QT pun kamu dah tahu, right? So only Q2, but you don't know what is the value of the forces, the total forces. Okay, so how you need to find Q2 if you don't have the answer of the forces? Okay, go back to the questions again. Okay, so point Q1, Q2 are 2 point charges located at these positions, and then the value, okay, the value of Q1 is given to you, and then you need to determine Q2 if the force at test is QT. Okay, so this is QT, has no AZ component. What does it mean? Okay, so if you look here again, QT, which is here, whatever forces, whatever electric field intensity you want to find it here, it will be no AZ component. Okay, again, all right, so at QT has no AZ component, it means that whatever forces and whatever electric field intensity, so you know that these two values have this it is a vector, right? We have AX, we have AY, and we have AZ. But it mentioned here that there is no AZ component. Okay, so what you can do is that you just take that value, okay, this one over here just now, okay, you can just put it, right? So you just take this AZ component, and negative 0.243, and divide by, so the negative 2Q1 divided by 2.243, and Q2 1 over 1 cube. Okay, just take the AZ part. All right, and you equal it to 0. Okay, so just ignore this one. Alright, dia tadi ada tulis 1 ke? Tak ada kan? So just it means that AZ is 1 lah, bukan negative 1 like this ataupun negative 2 like this. So it's just 1. So that's why they just letak 1. Alright, so take this value over here, and you know that it's equal to 0, and you know the value for Q1. Okay, so the final answer for Q2 will be this one. Okay, so this will be the answer. Alright, so boleh ya semua? Okay. Alright, good. Sekejap ya. Okay, so we continue. Right, so we already gone through this Okay, so electric field due to the continuous charge distribution. So we know that before this, we just only talking about a few charges, okay, a few point charges. And now let's say the point charges is in a line, okay. Okay, when there is a many charges, it will produce a line and what we call as a line charge, rho L. And when we have many line, it will produce a surface and we call it as a surface charge. And when we combine all the surface, we will have this volume charge, rho V. Okay, so now this is kita dah go through hari tu, so saya just skip. Okay, so you can see here. So for point charge, the equation is just Q equals to Q. Okay, and then for line charge, the Q is equal to the integrations of rho LDL. Okay, it's the differences between the distance of or the length of this line. Okay, so that's why we have DL. All right, for the surface charge, we have the charge will be equal to the integrations of rho s ds. Okay, so because we have this the surface area, so you need to know which surface and which coordinate system are you using. Okay, and then we have this volume charge, which is q equals to the integrations of rho v dv. Okay, and the unit for Q is just coulomb. Okay, but for this one, it is in coulomb per meter line charge. Okay, for surface charge, it will be coulomb per meter squared, and of course, for the volume charge is coulomb per meter cube. All right. Okay, so just now it's just a single charge or the line charge, surface and volume. So now if we want to find the value of electric field intensity for the line, for the surface and for the volume, so this will be the equations. So you just substitute instead of this just for a single charge. Now we have a line charge. So you just substitute the integrations of rho LDL into this Q. So it will be something like this. Okay. Same goes for the surface and also the volume. All right. So, okay. So this is just to change the value of this vector. Okay. The distance vector. All right, so this is already done. So we just go through. Okay, so this one. So now, how to solve the problems that related to the charge distribution. So charge distribution here, meaning that you need to find you need to solve the line charge, the surface charge, and also the volume charge. Okay, so like here, electric field due to the line charge or due to the surface charge. Panjang. Equation dia panjang I mean solution dia panjang. Okay, so we only cover two. Kejap ya. Alright, so we only cover two. Only for line and surface sahaja, kita tak cover untuk volume because it's a bit complicated. So we only cover surface and also line charge. Okay, so how to solve these problems? So there are 5 steps altogether. All right, so first, of course, you need to choose and write the right formula. Okay, so to choose what? To choose the equation. Okay, so it's either the questions is either for the line charge distributions or is it for the surface charge distribution. Okay, you know that there the equation will not be the same for both. Okay, so we have this for line and this is for the surface. All right, so you need to know the question is about line or about surface. Okay, so if line, you choose this one. If surface, you need to choose this second equations. Okay, right. And then the next one will be identify the parameters. So identify the parameters, it's you know that the equations is E equals to the integrations of rho L dl over 4 pi epsilon times dengan dia punya directions vector. Okay, so that will be the parameters. So you need to know what is the distance vectors, what is the magnitude, what is rho L and everything. So that will be the identify the parameters. And then when you have this all the parameters, so you need to substitute inside the equation again. Okay, and then this do identity test is just how you solve the problem. Okay, so we have these integrations. Okay, dalam bentuk something like this. So to make things easier, so it's given to you. So if you see the equation yang ada something looks like this or this one, so you can just substitute to get the answer for the integrations like this. Okay, there are two, so you need to identify which one that you need to use. Okay, and then the last one you just solve the problems. And this is another notes given to you. If you see if you have the infinity plus infinity, it will be equals to 2, infinity minus infinity is equal to 0, and so on. Okay, so this is only apply in electromagnetics. Okay, not in maths, but only in electromagnetics. All right, okay, so we go through for the first one. All right, so for this one, you need to find the electric field due to the line charge. Okay, so how to calculate the electric field at a certain point generated by a line charge distributions. So instead of before this, we only have 2-point charges or multiple point charges. Okay, so now we have this one single line charge. Okay, so we have only one single line charge, and you know that this line charge will produce electric field intensity in all around, okay, in all directions. So this line charge will produce the electric field in all directions. And now the question want you to find the electric field somewhere here, denoted as P. Okay, so you need to find the electric field at this point P. Okay, so now if you look here, your line is at which axis? What is the DL of your line? Can someone answer it? Okay, so this is apa ni? When we talking about a line, so it will produce what we call as just now electric field intensity in all directions. So this electric field intensity in all directions, it will membentuk something like a cylinder, right? Kalau kita ada point charge, so it will transmit at all directions. Dia akan membentuk something like a sphere. Okay, kalau dalam bentuk line, it will bentuk something like a cylinder. Alright, I hope you understand that. Okay, so please imagine. Okay, kamu ada this electric field in all directions. So dia akan membentuk dalam bentuk cylinder lah. Alright, so that's why kita gunakan this cylinder punya coordinates. Okay, and now what is DL? Can someone answer me what is DL? So you know that we have DL for cylinder ada 3. So what is DL for cylinder? Can someone tell me first?
dz.
Okay. DZ. Anyone else lain? Please. Ay, ni nak kena panggil ni. Alright, so can we have Azhar, can you answer the questions?
Tak dapat bayangkan medium. Tak,
Apa dia?
tak. Maksud saya macam nak
Nak.
dia back to basic yang sebelum ni kan medium.
Yes. Kamu tak boleh nak bayangkan, is it? Azhar? Okay, right. Kamu faham yang the coordinate system before. So we have DL untuk the coordinate system for the cylinder, right? Still ingat lagi? Okay, so what is DL untuk cylinder? Untuk cylinder. So please everyone make sure your notes, the Cartesian coordinate, cylinder and the spherical is by your side sebab you need to use it. Okay. So
Medium
Azhar,
nak semua DL ke?
yes, saya nak semua DL. Please.
Diro.
DL, Diro, DV.
Satu-satu. DL dia ada 3. What is it?
DL rho.
DL rho. Anyone can help?
DL equal to Diro arrow.
Diro arrow, okay. That is one.
DL is equal to rho dv AV.
Okay. Another one?
DL is equal to dz AZ.
Yes. Okay. So yang lain dapat tak? Please refer back to your coordinate system and look back at the cylinder punya DL. So you can jumpa semua DL yang ada kat situ. Alright? Okay, make sure that notes is by your side. Okay, so we are going to use it sekarang. Okay? Alright, for this question now, look at this DL. So which DL is this? Kita ada 3 tadi. So which DL is this?
DZ.
DZ, yes. Okay, because it is on DZ line. Alright, so if you look into the cylinder, you can see that kita ada 3 tadi, right? So this is on DZ line, so that's why DL dia sama dengan DZ, AZ. Alright, it's not dekat rho dv ataupun it's not at the d rho a rho. Okay, so DL sama dengan DZ. Alright. Okay. Okay, so again, tadi ada 5 steps to solve this problem. So, but first I want you to, when you have the question something like this, what I want you to do is that you draw something like this. Okay, so you have just now, this is the questions and the figure sometimes is given to you and sometimes it's not given to you, but you need to draw. So if you have a figure something like this, you need to draw like this. Okay. All right. So you know that the charge is here. Okay. At dz. Okay. dl equals to dz just now. Okay. And please draw this vector. Okay. This is the point P that you need to find. So please draw this vector. Okay. So how to draw this triangle is that you know that this is from the line towards your position P. Okay, from the line towards the position of P, okay, you draw one straight line from your line charge towards P. So again, you draw one straight line from the line to the point P. Okay, ataupun point yang kamu nak cari. And that line will be your distance vector R. Okay, ataupun the distance. Alright, R. Okay, again, you draw one single line from your charge. Okay, let's say it's line charge. From your line charge toward the points of you need to find. So P, and that will be your R. Okay, that will be the first one. The second one, take the starting point of your line just now. So going up towards atas and find the other way that to the P. Okay, jalan lain untuk ke P. So this is one straight line and this is another line. Okay, so this another line is just how you want to find because you need to use the parameters rho, z, and phi, right? So this is the other way. So take from the starting point of your R towards the P. Towards P. Okay, so what you need to do is you need to going up for Z and then from there towards your P. So going up will be Z and towards your P will be rho. Okay, that is your apa ni? Radius. Okay, so fahamkan tu dulu and make sure you draw inside your notes. Okay, sekejap ya. Okay, so let me repeat again. So you have your line chart just now. Okay, so what you need to do is that you need to take or draw a line from your line charge towards the positions of your P. Okay, that will be your R. And then draw another way towards your P. So this will be the way. So starting from the start of your R, going upwards, and then from there going to P. Okay, so going up here will be Z. All right, will be the value of Z, and going towards P over here will be the value of your rho ataupun radius. All right. Okay, so the first step daripada yang tadi tu, kan kita ada 5 steps. So the first step you need to know what is the equations. Okay, so you know that this is a line. So you need to use this equation, which is the integrations of rho L dl over 4 pi epsilon r cube r. All right, the second will be identify your parameters. Okay, so this is the parameters that you need to know. So you need to know what is your dl, what is your distance vector, and what is your magnitude r. Okay, so there are 3. Okay, so first one. All right, so first one, what is your dl? So again, the charges are arranged along the z-axis, okay, along this line. So meaning that dl will be dz. All right, so ni tadi saya dah explain. So dl will be dz because dia dekat z line. Okay, and then next one, how to determine this r. Okay, so yang saya explain ni tadi is how to determine this distance vector r. Okay, so again, assume we are looking from point A, okay, here, to the observation point P, this one. Okay, so what you need to do is draw a single line from point A towards P, so that will be your R. Okay, so your R will be the combinations of the line over here and the line over here. Ataupun the value over here and the value over here. So in this case, we have Z and rho. Okay, so yang kat sini dia just tulis DZ. So jangan letak DZ, that will be make you confused. Okay, so just Z sahaja. Okay, so your R will be, this line over here is the value of Z. Okay, what is the positions of Z? So Z, A, Z. Okay, AZ is the direction, it's going upwards, so positive. So value of Z to the directions of AZ plus dengan value of rho towards directions of A rho. Okay. So everyone understand tak yang ni? Macam mana nak dapat R? Anyone yang tak faham lagi? Boleh?
InsyaAllah boleh Pak Madam.
Okay. Okay, so again, take 1 point from your charge towards P and that will be your R. So R, kamu tahu dia adalah combinations of a vector. So we must have AZ, A rho, A phi. Okay, so in this case is the cylinder. So that's why ada AZ, A rho and A phi. Tapi for here is just involve Z value dengan rho value. Okay, normally dia ada dua sahaja. Alright. Okay, so from there you need to find the magnitude of R. So that magnitude will be again, this is Z squared plus dengan rho squared and square root the whole thing. Okay, sama macam before. Okay, so the magnitude is just kamu dapatkan yang depan ni saja. So Z and rho square root and square dengan square root kan dia. Okay. So bila dah dapat all these thing, kamu kena substitute back inside the equations. Okay. Alright, so when you substitute this, it will be something like this. Okay. So you have rho L dz z a z plus rho a rho. Okay, tengok balik betul-betul. Okay, so you know that before this we have rho L dl dengan R divided by 4 pi epsilon the magnitude of R. So kamu masukkan all the parameters just now into the equation. So dl will be dz. This is your R, the vector R, divide the magnitude of R. Okay. All right, so next steps. The next step is that you need to solve these equations over here. Okay, then by looking at this, okay, in here by symmetry, the contributions along AZ add up to 0. Okay, so it eliminates Z elements. So what it means by this one is that when you look into this value just now, okay, so it can be the positions because kita ada the Z is from negative infinity to infinity, so it can be any side, either by the positive side yang kita ambil ataupun either by the negative side yang kita ambil. Okay, so bila kita sum up this positive and negative side of Z, ia akan jadi 0 ataupun it will cancel out. Alright, so in here, what you can see is that, okay, by symmetry, the contribution along AZ add up to 0. So we need to eliminate Z elements. So where is Z elements? So Z element is this one. Okay, so this thing will be equals to 0. Alright, so again, kalau kamu nak senang faham, which one we need to cancel out is that kamu just tengok where is your charges, where is your line charges ataupun surface charges. Okay, so in this case the line charges is at the Z punya positions. Okay, so just take this Z punya elements equals to 0. Okay, so you just left with this. Alright, and then rearrange back the equations. So take out everything yang kamu tak perlu untuk diintegratekan. Okay, take it out. Okay, rho ni pun boleh letak kat luar sebenarnya. Alright, so it will be dz over z squared plus rho squared 3 over 2. Okay. Ini dia rearrange balik when dia dah eliminate this Z punya part. So the rearrange back, it will be something like this. Okay. Right. So from here, what you need to do, the next step will be do the identity test. Okay. So if you need to solve this one, it's a bit difficult. So that's why you need to have this identity test. So it will be much more easier for you to solve these integrations. Okay. All right. So look at these equations. So which identity tests that are similar dengan this equation? Is it the first one or the second one? Which one?
First one.
Pula. Okay, so if we look here, du sama juga dengan dz lah for our case. So we have dz sahaja kat sini. Kita tak ada z dz, right? Kita tak ada z dz. So we only have dz. So we choose this one. Alright, so bila kita choose this one, so gantikan all the value to here. So U is Z, M will be the row. Okay, see it properly. So U will be Z, M will be the row. Alright, so substitute. Okay. So du tadi dah jadi, yang ni dah jadi Z, right? So we have Z. Alright, and then we have row squared. M ni jadi row, so we have row squared. And this dalam kurungan ni Z squared plus row squared. Okay. Kat mana hilang ni? Dia hilang integrations. Okay, we have this integrations pula. We have this square root. Okay, tak ada square root di sini. Alright, so this supposed to have a square root. Okay, so please substitute inside all the values Z and row, and don't forget this ada square root, ada tertinggal square root kat sini. Okay, and then again you integrate from negative infinity to infinity, because daripada gambar we can see here from negative infinity to infinity, ataupun soalan dia infinite. Ada tak soalan dia? Oh, tak ada tulis . Okay, so selalunya dia akan cakap infinite. Okay, infinite meaning that daripada negative infinity to infinity. Alright, so where are we just now? Okay, here. So kita dah integrate dia, so we need to solve this one from negative infinity to infinity. Substitute inside this, inside the Z, and you know that this row and row here will cancel out, and tinggal one row, you just take it out. Okay, so the row is over here, and then substitute this Z with negative infinity and infinity, so you will get something like this. Okay, boleh, so try buat, solve it. Okay, try buat balik dari mula sampai semua siap lah. Ni tak habis lagi, ada lagi. Okay, so this arrow ni kamu boleh letak kat luar because this is just the directions. You can just take it out and put it outside here. So this will be infinity over infinity squared plus row squared. It will be infinity, right? So this is negative infinity divided by infinity. Okay, and then please use that just now the value of infinity tadi. Infinity plus infinity jadi apa? Okay, infinity tolak infinity jadi apa? Alright, so we have it just now before, in the slide before. Okay, so please try and solve the equation until you get the final equations for E. Alright. Okay. Done, everyone? All right, so from this last equation here, so you simplify it. So you will get something like this. Okay. Infinity divided by infinity and negative infinity divided by infinity. So this one will be equals to 1, and this is also minus and minus will be 1. So you will finally get this final equation for your E. Okay. All right, so we can continue to the next one. Okay, so this is for the line charge. So next will be due to the surface charge. Okay, so how to calculate the electric field at certain point generated by a surface charge distributions. Okay, and this is, all right, so the point of valuation is here, P, and the height is H. All right, so what is the equations that you need to know? The first step, choose your equation. So which equation is that? Okay, so this is your surface charge. You need to find the point of observation over here at 0.00 H. Okay, so right, so the equation is this because it is a surface charge. All right, so draw it again. This is the surface charge just now. So you need to find the point over here, 0, H. Okay, first you need to identify the parameters R, the magnitude of R, and also ds. Okay. So again, if you look over here, what is the surface of this? Okay, please refer to your coordinate systems notes. Okay, and look into the ds for cylinder. Okay, so which surface is this? Is this the side surface, or is it a top surface, or is it the front surface?
Top.
Can someone answer me?
Top surface.
Okay, so it is a top surface. Alright. So yang lain, yang senyap je yang lain ni, make sure kamu tahu ya semua. Orang yang sama je jawab.
Madam, macam mana nak tahu dia top surface, madam?
Okay, look back your coordinate system punya notes. Okay, so look at your coordinate system punya notes. We have 3 surface, right? One is top surface, one is front, and one is side. Betul tak? Siapa yang tanya saya tadi?
Saya, madam.
Mizan. Okay. So, kalau kamu comparekan every surface yang ada, kamu tengok is it this top surface ataupun dia adalah front surface atau dia adalah side surface, because now dia locate at Z. Okay, the normal to the surface dia dekat Z. Alright, so the only surface for the position yang dekat Z is the top surface. Yes. Okay. Kalau the positions of this surface dekat phi, that will be your apa namanya? Side surface. Alright. Kamu tengok dia punya directions of the surface. Okay,
Oh,
kalau
dia
top,
determine by direction lah, madam.
kalau top dia directions dia dekat AZ, betul? Kalau
Yeah.
side dia dekat A phi, kalau front dia dekat arrow pula. Betul lah, arrow kan, betul. Okay, so this is dekat AZ, so meaning that this is dekat top surface. Alright, so that's why your DS will be rho d phi d rho. Rho d phi will be this curved line over here. That will be your rho d phi. And the straight line towards the origin will be d rho ataupun kamu punya radius. Okay, so rho d phi d rho. So that will be your DS. Alright, so next. Next is again to find your R. So macam mana nak find R? Okay, tadi kita ada line. So sekarang ada surface. So what you need to do is that take the end of your surface. So surface ni selalunya dalam bentuk circular. Okay, so take the position at the end of your circle. Okay, and then go towards the point of observation P. So that will be your R. Alright, and then another way towards your P again, start from here, going in and going up. Okay, so go in and then go up. So what is go in? Going in inside here, what is the parameter for that? That will be your radius ataupun rho. Okay, so but now the rho is that you're starting from here towards the origin. Maknanya dia going negative way. Betul tak? Okay, they're going inside meaning negative way. Kalau they're going outwards, that will be the positive way. So because of that, we have we start from here towards the origin. So that's why we have negative rho A rho. And then again, it's going upwards. That will be plus Z. Kenapa U pula? Dia jadi AZ plus Z AZ. Alright. So again, going in will be negative rho A rho, and going up will be the positive value will be Z AZ. Okay, towards your P. So you have your R is this one. Okay, so let's say the position, let's say the position P is somewhere here. What will be your R? Can someone answer me? Instead of here dekat atas, so now your P is down here. What will be your R? Can someone answer?
Negatif madam.
Negatif Z.
Apa dia? Your R. Siapa nak jawab? What will be your R? Anyone?
Jadi negatif rho A P, negatif Z U Z A Z.
Negative rho A rho dengan?
Negatif Z A Z.
Yes, correct. Betul. Okay, so kalau dia dekat bawah, so it will be again negative rho A rho, and going down will be negative Z A Z. Okay? Alright, pandai. Okay, so the third one will be the magnitude. This one. So the magnitude is just take the value over here, square root and square dengan square root kan dia. So you will get something like this. Okay, and then from there, take all these parameters and substitute inside this equation again, inside these equations. Okay, and you will get something like this. Alright, so take it out semua yang kamu tak integrate. Okay, and then just leave apa yang ada dalam ni. So this one will be your DS. Okay, rho dv d rho, and this is your R. Okay, and this is your magnitude. Alright, because dia cube kat sini, so dengan square root yang ada, so dia jadi 3/2. Okay, to the power of 3/2. Alright, from here, you know that these conditions of symmetry tadi, so we need to cancel out one of this. So which one that we need to cancel out? Which value that we need to cancel out? Someone please answer.
Row.
Row, betul? Okay, so we need to cancel out the row part. Okay, because this row, you look here, dia dekat row kan? The value of this circle. Okay, so the circle can be smaller or can be bigger. Kita boleh ambil the value starting from here to here atau kita boleh ambil from here to here. Right? So from here will be a negative, will be row plus dengan Z untuk R. Okay, so that's why what it means by we have this negative part dengan positive part. So when we combine these both for the row part, dia akan cancel out. Okay, so that's why this row arrow kita akan cancel out. Okay, and the positions of Z dia tak berubah, dia hanya satu tempat je dekat value dia Z equals to 0 kat sini kan. Okay, so we just keep the Z punya elements, okay, and we cancel out this. All right, so you have that one. So rewrite again. So you just left with this. Okay, so rho S over 4 pi epsilon, rho dv d rho, and this value of Z elements. All right, from here, you need to choose the identity test just now. So which identity test that you need to use?
The second one.
Second one.
Yang mana identity test yang kita nak guna ataupun kita tak perlu pun identity test? Which one? Cuba kamu rearrange balik.
Tak perlu guna.
Kan? So let's say here row S, row dengan d row kita kena integrate dia, betul? Okay, so integrations of row d row. So bawah dia ada row juga, so kita kena divide with Z squared plus row squared. Okay, power of 3/2 dengan the next integrations is dv. So integrations of dv. Nampak tak? Okay, so kamu rearrange balik because of this is a surface. Okay, so that's why we have double integrations. Okay, so we have dv and d rho. So rearrange balik, kita ada dua integrations. Okay, how to write it? Susun dia dulu. Dan kita tengok kita perlu atau tidak guna identity test. Okay. So see when kita susun. Alright, so now we have two integrations, double integrations. So the first integration will be for the row. Okay, so we have rho d rho divided by rho squared plus h. So why is it h here? Sebab kita dah gantikan h dia dekat Z. Okay, it's given to you that the Z value is H. So dia substitute awal-awal kat sini. Alright, so this Z on top of here, dia akan bawa keluar because kita tak integrate the Z. So you can just take it out. So again, this Z is equal to H. Alright. And then we have this first integrations of rho. So what is the limit for rho? Is that from 0 until rho. Kita tak tahu berapa value dia. We just put it as rho. Okay. And then we have this second integrations. We have d phi. This d phi over here. Okay. So we have d phi. So d phi is the limit for d phi is fixed. You know that it starts from 0 until 2 pi. Okay, so from here we can say that this part we need to use the identity test. Okay, so this one. Alright, sama kan? This rho d rho divided by, okay, here. Rho d rho divided by all these things. Okay, and kamu akan dapat dalam bentuk this. Okay. Alright. Okay, so rewrite again. So meaning that kamu dah integrate dia. So it will be rho as H over 4 pi epsilon. And then this is for this one. Okay, it will be -1 rho plus dengan H squared. And kenapa 3/2? Okay, so this here, dia jadi supposed to be 1/2 ya. So kamu tulis 1/2 is not 3/2. Alright, so -1 over rho squared plus H squared to the power of 1/2. And then the limit is 0 until rho. And then we have this d phi. When you integrate d phi, you will get phi. Okay, and then the limit will be from 0 until 2 pi. Okay. Alright, so what is the final answer? Kat mana tadi? Here kan? Sebelah tadi dekat sini. Rho as H 4 pi epsilon -1 rho plus H. Okay, ni 1/2 still not 3/2. This is 1/2. And then the limit is 0 to rho. And then this one, the limit is 0 until 2 pi. Okay, so please solve this thing until you get the last one will be this. Ataupun this one. Okay. This is the last one. So let's say the value of rho dia tak bagi tadi, we just put as rho. So let's say the rho is infinity. So when you substitute the infinity at this, so it will be, this part will be 0 and this will left only with 1/h. Okay, so you have this one. Alright, and then you can cancel out this, H dengan H cancel out, and you will left only with this rho S over 2 epsilon to the directions of AZ. Okay, and the unit is volt per meter. All right. Okay, so kamu salin yang the last answer. E, the electric field intensity is equal to rho s over 2 epsilon to the directions of Az. Okay. Then yang ni kamu solvekan lah. That is mathematics punya part. Alright, so this is the next one. The next one, if you look into the questions, it looks like a surface tapi sebenarnya dia adalah circular ring. Okay, this is only a ring. Alright, so when it is a ring, it will be a line. Okay, it will be line charge distributions. Okay, because dia bukan surface, dia hanya line. Alright, so surface tadi equations of unit to use cos r start from the end of the circles toward the point of observations. Okay, and we have this the radius is a. Okay, rho a rho plus dengan z a z, right? So it will be a rho dengan h a z for your r. Okay, they substitute z into h and substitute rho into a. Okay, and what is your dl? All right, this is line. So what is your dl? This is the curved line. dl for cylinder ada 3. One is dz, one is d rho, and one is rho d phi. So d rho will be the radius, dz will be the height of your cylinder, and the curved part will be rho d phi. So your dl will be rho d phi. Okay. All right, so this is the value just now. This is the equation, and this is all the parameters. Okay, and then substitutes the parameters into the equations. And again, you need to cancel out one of it. So of course, you cancel out the a rho part because that will be the symmetry part. Okay, and then rearrange back the equations. Okay, if you look here, the only integrations that you need to find is d phi. So it's good for you. So d phi hanya sikit je lah. Alright, so take out everything except d phi. Itu je yang kamu nak kena integrate. So the limit for d phi is 0 until 2 pi. Okay, so you integrate that, you will get this answer. Alright, and the last answer will be this. Okay, so it's proven lah daripada the questions. Alright, so for this question, this is the answer. So try to do it. Okay, so this is the answer for this question. Okay, cuba buat. Alright, so kita ada slide lagi ya? circular ring. Alright, so saya go to this sikit je lagi ni, electric flux density. Okay, so this is electric flux density ataupun we write it as D. Okay, D in bold D because D dia dalam vector. Okay, so the equation for this electric flux density is D equals to epsilon E. Okay, it's not only epsilon naught, dia adalah epsilon. Okay, D is equals to epsilon E. Alright, ataupun we have only electric flux. Ni density, ini just only electric flux and we use this symbol psi kan, kalau tak silap. Okay, this symbol flux is equal to the integrations of d dot ds. Okay. Okay, how much the flux density in a surface area. So that will be your flux. All right. So D can also be written as this one. D is equals to Q over 4 pi r cube, the directions vector AR. Okay, because you know that D is epsilon E and this is E. Okay, bila kita substitute inside it, dia akan cancel out this epsilon punya part. Okay, so that's why you only get this one as your D. So D is equals to Q over 4 pi r cube times dengan the directions vector. Alright. So this one hanya, okay, this is the unit coulomb per meter squared for the electric flux density. And then this is just to show the electric flux line. Okay, so when we have two charges, two same charges, it will repel. And then we have these positive and negative charges, it will attract each other. Okay, so this is the flux line. Alright, so kalau kamu tengok when it's negative, the flux line will be going towards the negative value. And when it's positive, it's coming out from the charge. Okay, so bila kita combine positive and negative, so it will attract each other. Alright, so this is another example. Okay, so what I want you to do is that continue with this exercise. Alright, and the one, this one also, practice exercise. Okay, and then kita discuss in the next class. Okay, or if you want to ask me, you can just WhatsApp me. Alright. Okay, so see you on the next class, which is on Monday. Okay? Boleh ya?
Okay, madam. Okay, madam.
Alright, try to do it first. Nanti kamu akan nampak. And saya akan bagi soalan lagi. I will give you in either in WhatsApp ataupun dalam Google Classroom. Okay? And try to do it. Alright? Okay, Assalamualaikum.
Waalaikumsalam, madam. Thank you, madam.
Alam Enda. Thank you,
Bye-bye.
madam.
Thank you, madam.